We're going to now turn our attention to RESTful APIs. The idea here is that on the server side of our application, we want to have a service available to our user interface that provides access to the data that we've been figuring out how to store using objection and connects in our relational database. So a RESTful API is kind of the standard way to provide that kind of access to an application or to another program. It's going to give us a service that we can use to consume data from the back end in order to be able to display it on the user interface, and vice versa. When we have information that's being input into the user interface, we can send it to the RESTful API and have it save that information out to the database. So the central idea around a RESTful API is this notion of a resource, a web resource in particular. So what are we talking about when we're talking about a resource? Well, originally, and this is going to kind of take us back to the very early days of the web, the only thing that the web really knew how to serve was just a document or a file that was identified by some URL. You'd type the URL into your client, and it would fetch back the contents of the document that you named. Now that's become quite a lot more generally defined in recent years. So a resource is defined in the following way. It's anything or entity that can be identified, named, addressed, or handled in any way on the web. So as you can see, this is a very, very general purpose definition for the notion of a resource. So it could be a document, it could be a piece of data, it could be a spreadsheet, it could be a video, it could be an image, it could be CSS, it could be JavaScript, right? Anything that we can identify, name, and address in any way on the web counts as a resource. So it's a super general definition, which is great because it's really flexible, but we don't want it to be so general that we can't actually implement something that uses this idea of a resource. So we're going to start with this very general purpose definition of pretty much anything we can access on the web and kind of hone that into a specific kind of operation or set of operations that we can use when we're going to be implementing this server-side view of our information to support our user interface. I'm going to say a few things about the notion of a URI, a URN, and a URL. You're probably most familiar with the notion of a URL, but there's a whole family of these things that are all related to another. It's kind of a hierarchy in a way where one layer builds on the previous layer. And again, this is a thing that is intended to be used to identify resources, right? We're talking about resources back here. So the U and the R of all of these abbreviations stand for Uniform Resource something or other. Uniform Resource Identifier, Uniform Resource Name, and Uniform Resource Locator. So we're trying to figure out how do we get access to a resource. So the lowest level thing, a Uniform Resource Identifier, is basically just a string of characters. It's used as an identifier to pick out some resource that we're interested in doing something with, whether we're retrieving that resource or changing it or creating a new one with that name or that identifier, It's just a string of characters. There's a lot of specification and detail around this, what those characters can be and how they have to be escaped and those sorts of things. But for our purposes, we'll just think of this as an arbitrary string of characters, and that's going to be used by the other two layers in this hierarchy, the URN and the URI. So URI, really the most generic way of just referring to a resource in some way. So Uniform Resource Name is a formally defined URI. So it's not just the Wild West, any kind of characters that are extracted from the character set of allowed characters, but it's got a specific format, and we're going to talk about that in a moment. And the goal here is that the Uniform Resource Name, well, it names something. It's kind of the hello, my name is badge of the web. It's going to identify a specific resource. This should kind of bring to mind the notion of a key, right? We want to have some unique way to identify a thing on the web someplace. You could think of the Uniform Resource Name as answering the question who or what, right? Who are we talking about? What are we talking about? What's the resource? Who are we referring to when we're talking about this resource? So it identifies a specific resource. What it doesn't tell us, though, is where to find that resource or how to access that resource. And that's really the job of this top level, the third level notion of a Uniform Resource Locator. As you can tell by the name, it specifies a location for something. So whereas the URN is just an identifier, the URL says, how do we find that URN? Where do we go look to see if this URN exists, or to retrieve the current value of this resource, or to create a new resource with a particular name at some location? So it's the location to find a resource, and whereas the uniform resource name talks about who or what, the uniform resource locator talks about where do we find it. Let's drill down into these in a little bit more detail. So again, a uniform resource identifier is basically just a string of characters chosen from a particular character set, and both the URN, the uniform resource name, and the uniform resource locator are URIs. They're composed of those characters. Uniform resource name, again, is a way to formally identify a particular resource. So it's a formally defined URI. We're going to give it some more structure than just it's one of these characters, and it's going to be used to identify a resource. So it's going to, in particular, it's going to identify the resource by giving it some name in a particular namespace. So namespace, as you may be familiar with from, say, programming language terminology, is just a container to put names into, names of functions, procedures, classes, or whatever. In our case, we're going to be putting uniform resource names in a namespace. It allows us to kind of segment names into different groups. Those groups don't collide with each other. So, for example, we could talk about, for example, an automobile called Ford, or we could talk about an American innovator called Ford, and those are the same name, but they refer to very different things, right? One's a vehicle, one's a human being. So we might want to distinguish among those two things by putting them in separate namespaces. One that's going to contain all of our names for vehicles, and another that's going to contain all of our names for humans. The thing that the URI doesn't contain is the location or how we're going to get to this thing, right? It's just a name. It just identifies a particular instance of something. So kind of an analogy here is that the name is quite similar to a person's name, right? It's telling us who we're talking about. For example, something a little bit closer to information retrieval. If you look for this ISBN, right, that's the International Standard Book Number that's assigned to every publication. They're guaranteed unique because there's a central authority that allocates those things. And this particular ISBN is the ISBN number for Romeo and Juliet. If we wanted to take that and encode it as a URN, we might do it like this. So first of all, we're going to say it's a URN. And its namespace is ISBNs, International Standard Book Numbers, and this particular ISBN happens to be this string of digits and dashes. So the namespace again is ISBN, and that gives some meaning to that particular identifier, that particular name. Now that's great. We can say that's the ISBN URN for this particular play, but we still don't know where to find it. We need to have a location. So in addition to the URI and the URN, we're also going to have a URL, the Uniform Resource Locator, and this tells us how do we find a resource that's been identified by some URN. So it identifies a web resource, and it tells us not only where to find things, but how do we act upon it, or how do we get a hold of it. So if the analogy from before about URN corresponding to a person's name, the URL is sort of telling us where we would find that person. What's their address? How do we locate them? Here's another example. We're obviously familiar with URLs that we see in web browsers every day, like this one, example.org wiki main page. Well, this is answering kind of two questions, right? It contains a URN, and the URN is actually the wiki main page portion of it. That's an identifier for a particular web resource. It tells us it tells us what this is that we're trying to access. But it also tells us where we can find it. It's saying, hey, let's use HTTP and go to this server and use that location to look up the value or the contents of this wiki main page resource. So we're talking about a host and an access method, HTTPS. That tells us where do we go, this portion of it, and then what are we looking for once we get there. Now, of course, this is a web API that we're trying to construct. So we need to think a little bit more about how do we use the protocol of the web to be able to do these kinds of actions that we've been describing. So let's talk a little bit in more detail about the Hypertext Transfer Protocol, the HTTP. You've all used it. You've all used that phrase. You probably knew what it meant already, but let's go into it in a little bit more detail. First thing to state here is that HTTP has actually evolved over the years. The very, very first version of this, published by Tim Berners-Lee in 1991, he designated it version 0.9, so it wasn't really quite a full release yet. And it was quite limited, actually, at that point. The first version of the protocol that was actually kind of released into the wild officially was in May 1996, so not that long ago, really. And it was published in the form of what's called an RFC, which is an abbreviation for Request for Comment. One of the odd things about the internet, I guess, is that all of the design of the internet, all the protocols, the specifics of things like how TCP works, how IP works, how packets work, what sockets are, what the web is like, how HTTP works, that kind of stuff. All those details for pretty much anything that happens on the internet is defined in terms of this RFC. And RFC, the name Request for Comments, kind of implies its origin. Somebody who's connected with the network, with the internet, comes up with an idea that says, hey, we ought to implement this. And what they do is they publish that in a particular format, and they release it out into the wild for people to read and make comments on. So you're sort of making a proposal to say, hey, let's add this to the internet. Let's make this change to this protocol. And then other people have a chance to weigh in on that, give comments, and then you kind of iterate on that process until people decide, yeah, that's something that we want to actually include in the design of the web. Or excuse me, it's more broad than just the web, in the design of the internet. So RFC 1945, and these are hyperlinked here in the slides if you want to look at them in more detail. You can go read about how the definition of what the definition of HTTP said as of the 1.0 version. And again, this was released by, or the main editor of that request for comment, there's usually multiple people that participate in these, was in fact Tim Berners-Lee, who's the person who invented the web. It's a little unusual in a sense that most of the technology that we're familiar with on the internet is actually the result of a team effort. There's been a bunch of people involved in things like the basic protocols like TCP and IP and so forth. But Tim Berners-Lee pretty much single-handedly cooked up the idea of the web when he was working at the CERN Particle Physics Laboratory in Switzerland to share mostly physics data sets and physics papers among researchers at CERN. So it's a little unusual that there's kind of one person really that invented the web, and for that accomplishment, he's actually been knighted. Berners-Lee is a Briton, and was knighted by the Queen of England as Sir Tim Berners-Lee. The 1.0 version of HTTP didn't last a long time. You can see that the next version, version 1.1, came out just a few months later, and it's really this version of HTTP that we're still using today. It's been tweaked and extended and expanded, as you can see, through a number of different RFCs. And now we're currently, HTTP 2.0 has been proposed and accepted, and is kind of in the process of being implemented. Although this is now 5 years old, give or take, most of the traffic that's on the web is still using HTTP 1.1. Another thing I want to point out here that's important to be aware of in reference to the evolution of HTTP is that Berners-Lee is no longer the main editor of the specification as of HTTP 1.1. New guy called Roy Fielding is the fellow behind these RFCs, and his name is going to come back again as we talk a little bit more about what HTTP does and what in the world a RESTful API is to begin with. Now, this is another take on some of the capabilities of these different versions of HTTP. So instead of listing them kind of down the page here, I've got the different versions of HTTP showing up across the page. And I've given you some links to the RFCs if you want to go look at them. But what I'm showing here are what are called the HTTP methods. You're probably familiar already with GET and POST. You know, for example, when you type a URL into the address bar of your browser, that it's issuing a GET request to a server, and that server is going to return information to you, whether that's an HTML page or a CSS or a JavaScript function or whatever it is, an image, a video. you're getting that information from the server on the remote side. You may also recall that whenever you want to send information to a server, the way to do that over HTTP in a sort of the traditional way is you're going to define a web page, an HTML page that has a form in it. And when you fill out that form and push the submit button, that sends a request to the server again. It's usually a request to do something like log in or sign up or update my account or add something to my shopping basket or something like that. But that's going to be done by using what's called a post request. So there's two different methods that you can use. You're still sending a request to the same server, but the server can distinguish between whether or not you're sending a GET request in order to retrieve something or a post request, which is usually used to either add or update something. Now, what's maybe new to many of you is that there are a bunch of other methods that we're going to get into in more detail. In particular, we want to look at the put, the patch, and the delete, in addition to post and get. And there are others. The head method, for example, you can ask for the server to give you back just the header information for a particular URL. And one reason to do that might be that you want to check to see if anything has changed at that particular location since the last time you made that request, which you might have cached in the browser's cache. And that would save you the time of downloading that information again to your browser if you've already got a current cached copy. So there's other methods here that we're going to kind of skim over, but these get, post, put, patch, and delete are really important. Another word that's sometimes used to describe these is verbs. Right? These are HTTP verbs because they tell us kind of what we want to do with the resource that's been identified. Right? So we've got a name for something. We can identify its location with a URL, but we're also going to be able to use these verbs to say, okay, now that I've identified this resource, what do you want to do with it? Or what do I want to do with it? And so here's another way of looking at these methods or these verbs. I've copied them over here, the ones that we're going to pay attention to. And interestingly, importantly, these things correspond to parts of the CRUD pattern. You remember that CRUD, well, stands for create, retrieve, update, and delete. Some people say read for the R. But it's basically the four operations that we can do to pretty much any kind of data that we're manipulating, right? We're either going to create some new stuff, we're going to retrieve some existing stuff, or we're going to update existing stuff, or we're going to delete existing stuff. And those are really kind of the main operations. If you think about the discussion that we had about the data persistence layer, well, we had those same things, right? A select method, a select statement in SQL is basically doing the retrieve operation. An insert is creating something new. An update is, well, doing an update, or a delete is doing a delete. So those SQL data manipulation statements correspond to the CRUD pattern as well. And this is just obviously a really generic pattern that we use all across computing, and that includes in how we interpret the meaning of these HTTP methods or verbs. So when I send a post request, I'm indicating to the server that I want to create something new, which is consistent with what we were just talking about. If I'm signing up for a website and I go to a form on an HTML page and I fill in that form and hit the submit button, that's going to send a post request to the server, and the server is going to hopefully respond to that by creating a new account for me, or a new purchase, or whatever it is. When I want to get information from a website, I send a GET request, right? If I type something into my address bar, that does a GET request. It turns out that we can also do these other things. I can update information already on the site, and there's kind of two ways of going about that. I can use the put or the patch method, both of which were listed back here, right? I had these two guys. The distinction is that a put is intended to kind of completely replace a resource. So I want to completely overwrite the details of a product that I have in my online catalog. Whereas a patch is intended to do a partial update. I want to change the price of some product in my catalog, but I'm not replacing the product in its entirety. And then the delete, obviously, is going to delete something from the server. So armed with that information about what a resource is and what HTTP is in more detail, we're ready to tackle the notion of a RESTful API, which is kind of our focus here. Let me start by just talking about the notion of an API. API stands for Application Programming Interface. So it's a mechanism for interacting with some system of software that's a predefined set of functions that you can call, or methods that you can invoke, or requests that you can send that gives you access to the functionality of some other piece of software. So in a general sense, an API is a package that exports functionality to programs, right? I can use this API from a program that I'm creating. So here's a few examples of what we would think of as programmatic or programming APIs. And these are things that you're just going to invoke directly from your code. A simple example of this is the API that's provided in the Unix and C standard library. So I've listed things like fopen, fclose, fread, and fwrite to talk to files. You can think printf, scanf, malloc, free. Any of those functions that you are familiar with using from your C programming experience are part of a standard library that are defined as an application programming interface. This particular example that I've got here is the API for file access, right? All those functions that are part of the standard library that start with F are file access functions. In Python, there's a ton of APIs available in Python, many of which come built into the Python interpreter as you download and install it, and a ton more are available from on the internet. So, for example, here's examples of the gzip library, right? So there's a compress and a decompress that are methods defined in the gzip library that you can just use in your Python programs to compress and uncompress files. Or in Node, we've already talked a lot about the Node file system module, the FS module, that can read files, write files, delete files, append to files. This is another example that there's support in Node for the Internet Domain Name System. You can look up addresses, you can resolve addresses, and those are all part of this DNS package that's defined as an application programming interface that gives you access to some functionality by just importing it into your code and invoking it. So again, these are programming APIs that we're going to invoke from our code, but we can also define APIs that are accessed in different ways. Same kind of an idea. Let's expose some functionality that's going to be made available to other software, but instead of it coming directly from our program where we're actually linking in this code that we're going to use directly into our program, we're now going to access these APIs across the internet. So here's examples of web service APIs, and we're going to access these by making a request over the network, in the cases of these examples using HTTP. So you can talk to the Google API, the GitHub API, the Facebook API, the Instagram API, right? These are all alternative mechanisms for accessing the functionality that's available on these various websites that make it easy for your program to talk to the interface. So instead of you going to an Instagram web page and typing in information into a form or clicking on buttons and so forth in the web interface, you can actually refer directly to the Instagram API and send requests from your programs to ask Instagram to post things, to retrieve things, to give you information about the status of various resources that are defined in that context. And essentially what we're going to do as we create our own APIs in this course is create web service APIs. They're going to be quite a lot simpler and quite a lot easier to comprehend and use, but in principle, they're the same kind of functionality, or they provide the same kind of functionality that any of these more highfalutin web services provide. Okay, so let's say some more about some of the details behind a web service API. I want to spend a couple of minutes talking about this notion of a pattern. The web service API is an example of a pattern, more completely referred to as a design pattern. This notion of a pattern kind of was first formalized in the building architecture domain. So, for example, if you think about something like a three-season porch, right? That's a particular pattern for constructing a part of a home. So a three-season porch is basically, it's like a deck with a roof and maybe some screens on the walls that you can use except use in 3 of the seasons, so basically anytime except for winter when it's really cold. It's designed to be used in spring and summer and fall. And it's going to have certain characteristics. It's going to have a roof. It's going to be waterproof. It's going to have a lot of opportunity for airflow. There'll be large screens, and sometimes the walls are basically just made of screens. It's usually built on something that kind of resembles a deck that's attached to the back of a house in many cases. So the point here is that instead of talking about the specific details that I've just laid out that define a 3-season porch, we can just say, hey, this is a 3-season porch. And anybody who kind of is familiar with that design pattern, the 3-season porch pattern, knows what we're talking about. We might say something like a walk-in closet is another example of something like that you might find in a home, right? It's not a closet that's just sort of really shallow, that's only deep enough to store one row of hangers. It's a closet that you can kind of actually enter as a little room that has more storage and other features that you wouldn't find in a non-walk-in closet. So walk-in closet is another pattern that describes a common approach to providing storage in a home. So that notion of design patterns has made its way into computing and is a super helpful way not only to sort of think about different ways of building software, but to communicate those intentions to other people. So instead of having to describe in detail what you're after, you can just mention this pattern name and everybody suddenly is aware of the basic ideas that you're talking about. So in our case here, we're talking about a client-server pattern. And client-server is probably the most important pattern, design pattern, for any kind of networked applications. So, for example, on the web, of course, our client is our web browser, and our server is going to be the web server that is receiving requests from the browser and sending information back to the browser that the browser can then display or use to interact with the end user. So we've got a client that's the browser, a server that's the web server. But a ton of other things that are out there in modern networking follow this same basic pattern. So if you open up, for example, an SSH session or a PuTTY session, if you're a Windows user, to connect to a secure shell on a remote server, same thing. You have a piece of software that's the SSH client on your machine, and there's got to be an SSH server on the remote machine. When you send email, you construct the email inside of an email client, and when you push the send button, it's going to talk to an email server that's going to take care of delivering that mail to the destination. So again, that client-server pattern, very, very common in modern networking applications, and that's the same case here for our web services. So knowing that we have a client-server pattern, well, that's going to naturally mean that we're going to want to look and say, well, what are the details of the client and of the server? What do they do? How do they interact? What kind of services do they provide? Well, in our case, for a web service, our client is going to basically send requests to some resource, right? And I've shown here as the URI, just kind of using the most generic, the generic uniform resource thingy. It's going to use HTTP to send that request. It's going to specify an operation that says, what do I want to do with that resource? And that follows the pattern that we've just been talking about, that CRUD pattern that's using get and post and so forth. And it's going to say, what resource do we want to talk to? Okay. So we're kind of combining together the ability to locate a resource, to name a resource, and to specify an operation to be performed on that resource as part of this request that the client knows how to put together and send to a server someplace. On the server side, the server is going to receive that request, and it's going to determine what to do with that request. So in a sense, the server is going to figure out how it's going to accomplish this, right? It's going to see that request that's going to say, for example, create a new account for me on this website. The server is responsible for interpreting that request. It's going to be a post request because we're creating something new on the server. We'll talk about that in more detail as we go. But the server has to implement some code that responds to that request, that takes in that information and acts on it. So it's responsible with determining how to do that. And this is really the game that we're up to now, to implement these web services. We're going to write code that's going to take those requests in and determine how to implement the request, how to satisfy that request, the how, the what do we do now part, and do whatever the client has requested. Now, in addition to doing that action, the server is also going to give back some information to the client to give it an update as to what happened as a result of that request. In the earlier days, that response was often a document encoded in what's known as XML, the Extensible Markup Language. That's largely been replaced in most web APIs with a JSON response. So the server is going to send back a JSON string that the client can then decode and use to determine, did it work? What sort of messages do I maybe want to maybe send to the end user? It might also confirm that we made some changes to a resource. So for example, in the case of doing a post request, like we've been talking about where we're signing up for a new account, we might want to say, hey, yeah, we've created this new user. We might actually send some additional information about that creation. So for example, if we're implementing an API where I can create a new user, and that's going to result in an automatically generated user ID, it might be helpful to send that new user ID back to the client so the client knows, hey, I'm logged in as this user and the ID I have is 42. And when I want to do further operations against this user, say update information about the user's profile or something, I know in advance to ask the server to do this with user ID number 42. It might also send back links to additional resources. If there's other places we want to be able to refer the client to fetch additional information, the server can also include those things in its responses to these web service requests. Okay, we're finally to the point where we can start talking about what this notion of REST is. So REST is an abbreviation for Representational State Transfer. It's a kind of a highfalutin sounding thing, but it turns out to be intensely practical as well. So it basically defines a specific type of web service, kind of the semantics or the behavior of a web service. And web services that implement this notion of representational state transfer are referred to as RESTful APIs. So what in the world is representational state transfer? It posits the notion that there's this network of web resources, right, that we've been talking about, this notion that anything that we can identify out there on the web is considered a resource that has a name and a location. And it says that those web resources are somehow interconnected in a way that allows you to link them together and perform operations on them, like getting things and deleting things. And the origin of this notion of representational state transfer is this document. It's actually a PhD dissertation by a guy called Roy Fielding, which you'll recall from earlier is the fellow behind most of the recent RFCs for the HTTP protocol. So he actually wrote his dissertation and then essentially implemented it as HTTP 1.1, and now it's taken over the world as the means by which most web applications interact with servers. I've put in a link here to his dissertation. If you've never read a doctoral dissertation, this is a good one to start with. It's actually quite accessible, quite readable, and gives you a lot of the information about what's really happening behind the scenes when you're talking about a RESTful API. And as I said, it was used in the design of HTTP 1.1, which is what almost every web browser in the world is using right now. All right, so I want to try to tie all these pieces together and in a way that's going to give us some insight into how do we design a RESTful API. First of all, I want to distinguish between an element and a collection of elements. In particular, we're talking about resources. So we've been using that word resources in resource in a very general sense so far. But I want to give a little bit more detail here and say that a resource can represent one of two things. Either a single element, a single thingy, a single vehicle, for example, or a collection of elements, more than one of those things. And the particulars of how a RESTful API applies to an individual element or a collection of elements is going to differ, as we'll see in a second. First of all, let's look at some collection URIs. You can see that these are all web addresses with a particular server in mind, and then the resource portion of the URI is referring to a collection of things. In this case, it's a collection of users. We might refer to a collection of courses. We might, if we're talking to the Ivanhoe web API, we might refer to a collection of Sundays, right? And we can request actions performed on these collections by using the appropriate HTTP method, or verb as we've been talking about it, against a collection. We might also want to refer to individual elements of those collections. So these element APIs have some additional information. So rather than just referring to users in a very general sense, we can talk about users and refer to a specific user. In that case, for example, a user with an ID of 42. You can see that this is very different from the collection of users. When we're talking about the collection, we're talking about everything that's in that collection, all of our users at this particular URL. Whereas in the element case, we're just referring to a specific user. I want to do an operation just on that one user. If we're talking about courses as a collection, we might refer to a specific course. So here I've said, well, let's talk about Cause 436 as the specific course of interest. Not all the courses, but just that one. Or if we're going to the Ivanhoe's API, let's talk about Sunday number 17, not just the collection of all such Sundays. So with that understanding of the distinction between collections and elements, let's look at how this relates to those HTTP methods and gives us our RESTful API. So let's look at a collection case first. We'll use this URL that refers to our users collection. So all of these API endpoints that we're going to talk about refer to that users collection. And it's important to keep in mind that the various things that we can do with that users collection all are going to refer to the same URL. I'm not going to have one URL when I want to get a user and a different URL when I want to update a user. I'm going to just use that exact URL, the same one that identifies that user's resource, that collection resource of all the users, and then by specifying a different HTTP method, I'll be able to distinguish one kind of operation from the other. And on the server side, we'll see this when we learn how to implement the web services, the server side will be able to do different things based on the same URL, but different HTTP methods. Notice that I've also marked these out as things that are common and things that are rare. And going back to that slide that showed the kind of the CRUD pattern, right? We have our create operation, post, the retrieve is get, put and patch are update operations, and delete removes something. So I've got all of the CRUD pattern HTTP methods here, and some are used more commonly than others depending on whether you're talking about a collection of elements or an individual element. But I wanted to just be complete here. So when we post to a URL like this, a collection URL, normally what we're trying to do is create a new instance of that thing. I want to create a new element in that collection. So if I send a post request to this user's URL, I'm trying to create a new user. And what will happen is that the code behind that on the server is going to say, okay, this is the user's collection. The request is for a post. I'm going to create a new user of some kind. And in addition to the request saying this is a post, there's also going to be some additional information sent along the way from the user interface that says, here's the details of the user that we're going to create. So the server side is going to create a new user and return information about that user back to the client. Similarly, if I want to retrieve information about a collection of users, I can send to the same URL a GET request, and what's going to come back from that is a list of the details of all of the users. So same URL, and the post says I'm going to create something new. The GET says I'm going to get some information that's already there. It's the retrieve operation in the CRUD pattern. And because we're retrieving from our collection, we're going to get that entire collection coming back as the response to the GET request. Now there's some nuances there under the hood that, if we have a collection of 1 million users, we're probably not going to implement something that's just going to return all 1 million of them in response to that GET request. There might be some other other additional parameters that we're going to send to say, I only want the users that match this pattern, or I only want users, 1,000 to 1,020. So there's other details that go into this, but in the most common case, we're just going to get the entire collection. We can also use the other three methods that are shown here, but as I've marked them out, it's kind of rare to actually implement these. So a put is supposed to replace the entirety of a collection, or the entirety of a resource. And in this case, the resource is a collection resource of all of our users. So strictly speaking, if we were to implement a put request to this URL, we would be asking it to replace all of our users with some new set of users, which doesn't really happen very often. Similarly, if we were to send a patch, we would be saying, well, I want to replace some of my users, because put replaces the entire resource, patch updates an existing resource. Again, not super common in this case, because if we're going to say update a user, we're not going to talk about the collection of users. We're going to talk about a specific user. So it's going to be an element resource instead of a collection. And then finally, the delete, which is designed to remove resources. If we sent a delete request to the entire collection, it would be basically saying delete all of our users, which is probably a really bad idea from the point of view of the requirements for this system. I also want to point out that here I've said inactivate. It's very unlikely that once you've collected important data for your business or your organization in your database, that you're ever going to want to get rid of those data. Now, that said, you might have cases where, for example, a user wants to say it's a subscription service and they want to cancel their subscription. I no longer want to be paying for this. I'm not interested in the content you're providing, whatever it is. Now, one way to do that would be to literally delete that user from your database. And the unfortunate aspect of that is you've now lost historical information that might be useful to you in the future. Say sometime down the road somebody says, let's try to figure out what's the most common reason people have stopped subscribing to our service. You'd want to be able to go back and fetch up the information about those users who said, I don't want to be part of your service anymore. If you delete those data outright, you have no way of going back and getting that information. Whereas if instead you simply indicate that that user is no longer active and treat them as if they were deleted, then you retain that business data and you still don't charge that user anything and you're not sending them any information that they're not interested in getting any longer. So oftentimes what you'll do is include in the data persistence layer for something like a user that can be inactivated, an additional column in that user table that says whether or not the user is active or not. So it could be something as simple as a Boolean, right? Is this user active? Is this user not active? And then you define a query that would give you back, say, a list of active users. That's a much more common approach than actually outright deleting things. The other complication is that if you delete things that have primary key, foreign key relations to other things, you may also have to delete other objects from the database that refer to that user that you're about to delete, because you don't want to have other parts of your database that refer to non-existent users. So not only are you losing information about the user, but maybe additional information about the things that that user viewed, or the things that they purchased, or the things that they commented on, and so forth, that you really would rather not get rid of. Now, there's one additional caveat to that. The European Union in the last few years has enacted some very strict data privacy requirements, and most companies that are, all companies that are operating in the European Union have to adhere to those requirements, and that means American companies as well. So a lot of companies now have the option of literally deleting everything from you that's stored in their databases. They're supposed to literally get rid of all that data if you request that. And that would be a very different constraint to follow, where you don't want to just inactivate something. You want to allow the possibility that all of that data literally is removed from your system permanently in order to conform to those requirements. But we're not going to worry too much about that going forward. But it is the take-home message here about delete is you almost never actually delete things. You just sort of turn them off or inactivate them, deactivate them. And normally when I'm implementing a web API, that's the way I'll still use the delete method, but I'll implement it as a deactivation instead of an actual deletion. So in principle or logically, it's still deleting something, but in practice, I don't lose any data. Now let's turn our attention to individual elements. So instead of a collection style resource, we're talking about an individual element resource. And the URL that we're going to use here for this example is this one. You can see that it's not just the user's collection itself, but a specific user that has, for example, a database ID value of 42. So same idea here. We're going to send a request to that URL, and the purpose of that request or the meaning of that request or the how that's going to be determined by the server is going to depend not just on the resource identifier, the 42, user 42 here, but also on the HTTP verb that's sent along with it. And again, I've listed these things in terms of how common or rare they might be. Let me start here with the easy one, the GET request. This is very common, and because we're referring to a specific user, what we're asking if we send a GET request to that URL is to just give me the details of that one user. So you want to see your current profile or something like that in your user interface. You're going to send a request to the server to fetch up all the details for that specific user. Another super common one is going to be a patch request, and that would be used to update some portion of a specific user's information. So if a user wants to update their email address or their shipping address or something like that, you could send a patch request to this same URL referring to a given user whose information you want to update. And then in addition to that, you would also send information along with that request to say, I want to update this particular field to this new value. Less common would be to send a post request to an individual user. Now, in the previous example, when we were talking about the collections of users, posts get made all the time to create a new instance of that collection, to add a new user to the user list. But when we're thinking about posting to an individual user, it's not quite as common. It's often going to be used to do something sort of within that user's information. So for example, if we're trying to add an order for a particular user, we might send a post request to this user's URL with some additional information discussing detailing the order that we want to have this customer place. Probably a lot more common to actually post to the orders collection and include information about which user is placing the order than to use a post to the specific element. Another thing that's less common is to do the delete request on a user, again, for the reasons that we talked about before. We don't want to delete information that's going to cause us to lose business data in a permanent way. So in a lot of cases, what you're going to do, again, is do an inactivation of that user and not actually remove their information unless you're subject to some of these privacy constraints. And then finally, a put. You remember that put and patch both have to do with updating or making a change to an existing resource. The patch updates part of the user's information. A put is supposed to entirely replace a resource. So if the user was there, we're going to basically replace the existing user with a completely new set of information about a user. As you can tell, just kind of thinking through that, this is not something I'm going to do very often. Users aren't going to just sort of spontaneously change identities from one to another. I may very well update an existing user, but I'm not going to just replace one user with another. So this is an example of where the model kind of breaks down a little bit in terms of how frequently you're going to do these types of things. Finally, here's some resources that I've linked for you. You can go read about requests for comments. Again, the fielding dissertation is a very, very readable document that gives you a lot of information about what's happening under the hood in HTTP, and then some other links to REST and the notion of a URI.